Hey everyone, my name is Ahmed. I'm a data scientist at Mailchimp, and today Zero to Hero, solving the NLP cold start problem. So let me start off with the dream. You have some idea for a new product that involves NLP. So we train a model and engineer our product in such a way that users can contribute labeled data back into our system to create what's known as a data flywheel. Your product then enters a virtuous cycle of better data sets, which lead to better models, which leads to a better product, which leads to more users who can contribute more good data. The only problem is that the first version of your model in the system usually requires a lot of training data in order to get this feedback loop going. And this is known as the cold start problem. So in this talk, I'll walk us through how I solved that cold start problem at Mailchimp using ZeroShot Learning to build our user intent classifier. But first, I'll talk about Mailchimp and why we care about intent. So Mailchimp is an all-in-one marketing platform for small businesses. We offer a ton of features for our users, but we're primarily known for our email sending capability. And these emails that you send using Mailchimp are called campaigns. So why do we care about intent? Well, we did a lot of user research, and we found that our users expect us to play an active role in their marketing endeavors. They'd like us to generate designs and surface marketing recommendations for them, which requires us to know their marketing objective. This requires intent-aware products, and they need to be predicted at times since we don't always have that opportunity to ask. Here's a quote from a user research study last year. When asked what the biggest benefit to a smart platform feature would be, the user responded, "It'd be the confidence that all of the predictions, assumptions, and data that I'm making my choices off of are done with the right intent. Intent is key." So this kind of speaks to the fact that getting a user's intent right is invaluable to a smart tool. So let's talk about use cases for intent now. The Creative Assistant is a Mailchimp feature that automatically generates on-brand designs using assets from a user's website, landing pages, and campaigns. It captures things like your images, text, and brand colors to generate thousands of beautiful designs that can be shared across several channels. So when we're thinking about how we can include intent in a system like this, we landed on two use cases. So the first is that we use the predicted marketing intent to determine what copy to include in a user's designs. And the second is that we could use the predicted intent to inform which design layouts to use in the downstream designs that are shown to the user. You can imagine a case where predicted intent is to sell products, and so we use designs that emphasize the product image. And similarly, you can think of an example where the intent is to make an announcement or just to inform, then we might use a design that prioritizes the text more than the image. There are also use cases for smart recommendations. So the first is to recommend thoughtful recommendations based on what a user is intending to do. So this is by looking at their campaign in the editor, and while they're editing, surfacing a useful recommendation about the intent of what they're doing. So this example is, we noticed that you're creating a morning motivation email, and so we recommend that you use the time warp feature so all of your subscribers receive that email at the same time, respective of their time zone. There's a similar example of this where we notice that a user is writing a welcome email, and so we can recommend that they set up an automation for this instead. We also recommend an intent-focused campaign as an action. So if we know that a user is an e-commerce user and they haven't sent an email advertising their products in a while, we can recommend that they do that sort of as a marketing coach. And so let's return back to our cold start problem, which was the initial training data in order to start our data flywheel. So one common approach is to use human annotators, but that comes with a lot of issues. So it's, for one, costly. Two, it can be time consuming as well. Next, it could be really expensive. So if you have a really specialized task, you can think of labeling medical data, like medical images, then you might need something like a radiologist or a domain specialist. There are also legal hurdles for certain sensitive types of documents. So you can also think about the healthcare use case there, as well as legal documents and other forms of sensitive data. And so that's where zero-shot learning comes in. So zero-shot learning has become very popular over the last couple of years. Historically, it's meant just to learn a classifier or one set of labels and then evaluate on a totally different set of labels. But more recently, it just means to get a model to do something that it wasn't explicitly trained to do. And people use zero-shot learning for many pre-trained models, but some examples are question answering models, language models, and in our case, natural language inference models. And so I'll talk about the natural language inference task first. So natural language inference is a task where you have two sequences of text and you predict whether the two sequences contradict each other, they're neutral, or whether they entail each other. You can look at the bottom example of the table and see an example of an entailment. And that looks something like this, where you pass the premise and the hypothesis into a transformer model and you predict whether it's a contradiction, entailment, or neutral, and entailment in this case. What we found, though, was that instead of using the premise from some NLI data set, we could then just insert some arbitrary text for the premise. And then for the hypothesis, we could craft sort of our own sort of probing sentence found through experimentation of different hypothesis statements. In this case, determining whether the campaign text was talking about posting a review or not. And that looks something like this, where we'll have one premise text that represents, say, like the campaign text, and then we'll have many hypothesis statements, each for one of the intent classes. We'll pass it through the pre-trained model one by one and look at the entailment scores, and that can be seen as the prediction. And since we're using a transformer model here, we can observe the attention weights in order to sort of sanity check our hypothesis statements, since this is sort of an experimental and iterative step. So you can make sure that the model is capturing what you think it's capturing upon making that prediction. In this case, it found the word review most useful in determining that this was a post about posting a review. So then we're done, right? We have this zero-shot model, and we're able to predict using these various hypothesis statements that we finally crafted, and it seems to be doing reasonably well. Well, we decided to take a different direction and instead build a data set rather than just using the model out of the box. And that was for two main reasons. The first is compute. So just to give you an example, it took about 1 week to process 250 examples on a V100 GPU, which is the most powerful GPU available in Google Cloud platforms. Also, dataset flexibility is another reason. So when you create a data set, you're able to sort of rigorously quality test that data set and train many, many models on that data set. You're also able to add any data that you want, including out-of-domain examples. So our training procedure looks something like this. In the first phase, we collect data using a sample of campaigns and our zero-shot hypothesis statements that we've crafted through experimentation. So we'll take that text and pass it as the premise and pass all the hypothesis statements one by one in order to create this training data set. Phase two is training the downstream model. So we take that training data set, we pass it through a vectorization or embedding technique, and then we train our downstream intent classifier. And the outcomes are as follows. We have a Python package that we use in many different places of our deployment in order to ensure that the same intent predictions can be served no matter where you access them in the app. And also so that other data scientists can leverage this in their projects as well. There's also a Streamlit demo. So this helps us to be able to talk about the intent package internally and demo it to non-technical stakeholders. And if they like it, then we can incorporate it in the part of the app that they're working on, which will in return add even more users to our data flywheel. And the last outcome here is that it's available now in the Creative Assistant. And so we'll predict your intent, but also users have the opportunity to correct our predictions, which serves that user feedback component and feeds our data flywheel, and downstream makes our product much better. And so in summary, you no longer need to spend countless time and money on human annotators to cold start your NLP product. All you need is a powerful pre-trained model and a clever zero-shot learning approach to get started. And with that, I'll take questions.